or that records the respondent's attitude, right? This is just a code to identify each respondent. It is still a variable, but it's a variable that just represents a code. It doesn't carry much information apart from allowing us to differentiate between the different customers or respondents, right? Therefore, if we are going to work on these 5 variables that carry the information that we need, do we need to also consider ID as one variable that carries information in terms of what we are looking for? No. Therefore, what can we do with it? We have to filter it out. In other words, we have to try not to consider it in our analysis. That's why she is going to filter it out. Remember, from the very beginning, we always recommended, it is a must to always add a type in your node so that you can visualize the measurement of your data set, of your different variables.
So in the type option, just verify the sheer type of variables and which will help to identify their role in streams. And in this case, check whether all the variables are okay. So we can apply for, we can just apply it. And next is like we have to now add the switch node, which is used to find the correlation matrix, So for using the sim fit, we first go to output, and in the output we can find the sim fit.
She's explaining the purpose why she's looking for the sim fit node. If you intend to find the correlation between the variables, okay, can anybody tell me what the correlation is? Just theoretically, do you know what the correlation is? Okay.
The association.
The correlation allows you to see, okay, variables that have a certain relation without telling you which way that relation goes, whether it goes from A to B or from B to A. That's not what correlation tells you. It just tells you that A and B have a relationship, nothing else. So the correlation is expressed as a number located between -1 and 1. Okay?
And we can just go for the default option and just run, and we can find another node connected to this, so we can click it again and we are able to see the correlations.
So if we take a look at these variables here, okay, we can see that fast food, a variable in itself, if me and myself, we have a strong correlation. A strong correlation is a value that is around or is equal to 1. That says that the correlation is quite strong. Some textbooks says that the strong correlation is around 0.7 to 1. Okay? Now, if the correlation is around 0.6 to 0.2 and 0.6, they say it's a weak correlation. And if it's around 0, there's no correlation. Okay? But if the correlation is -1, means I have a strong correlation with myself, but my back and myself, we have an opposite correlation because I'm going this way and my back is headed toward that way. So this is the opposite.
So in this case, using swing fit, the correlation matrix is calculated based on approximation of frequency distribution, which can result in misleading correlation. So in order to verify it, we can use statistic laws. So for adding the statistic node, we have to connect it with the type, then go to output and add statistics. So in this case, we can double click it, and for examine option, just select all the variables, apply and OK, and inactivate all the statistics options. So for correlation also, just add all the variables, apply and OK.
Usually, okay, as you might be looking at some article or papers, usually it is recommended, it is a recommendation that when you're gonna add your correlation table, you have to consider adding the mean and the standard deviation in your correlation table. Okay? It is a recommendation. So, if it was me, although they recommend not to add anything from here, but I would still add my standard deviation and my mean here. Okay, anyway, you may continue, no problem. You can run it.
So we can finally run it. So here we can get the Pearson correlation among the variables.
Now, if we take a look at this table, because that table is only produced to confirm or to be in disagreement with the previous table. Because she was explaining that this is not enough to make sure of all the correlation. That's why we are running the statistics. Now, this table allows us to confirm what we have found in our slim fit node. And we can see, for example, if we take a look at vegetarian, okay, vegetarian only has a strong correlation with low meat. However, it's not correlated to fast food, filing, and hearty, which kind of makes sense for us, because if we're talking about vegetarian, a vegetarian will never be going for fast food, because we know fast food, they are oily, they have all kind of problems that doesn't relate to what a vegetarian stands for. Now, if we take a look at fast food, for example, again, fast food has a very weak correlation with vegetarian, what we saw earlier, but it has a strong correlation with low meat, filing, and hearty. Now, this might a little bit be in disagreement with the previous table, but we can still take a look at all the other correlation tables to see whether or not this is correct. Now, let's say hearty has a strong correlation with low meat, fast food, filing. I believe there's another way to see our table, right?
Yeah. Extend or collapse.
It's okay. So, what is important? Yes?
Yeah, I just wonder to know that strong.
So for that, we can go to the modeling and just add PCA or factor.
Okay, hold on. Modeling PCA factor. Okay, so you can see a lot of modeling here. Next week we will tonight, this week, and please go home to familiar all of this, okay? Next week, we will be focused on modeling. A little different from statistical data miner.
In this we can see that extraction method is principal component. So we can choose the default setting for this, and for export, just activate export. And in this case, firstly we will try to do it without rotation, without using rotation. And in this case, we can select the icon over 0. So we can apply and run.
Okay. Eigenvalue. Actually, eigenvalue will be higher more than 1, right?
Yes.
Yes. If you want to see all the components, you can see all of the 5 components. Okay. Or you only see the strongest component higher than 1. Okay. 组成分分析就是把好几个变数类似的绑在一起，相近的变数。Okay. For example, I talk about 你好吗 How are you? Okay, 元気ですか konnichiwa. And something that just say hello. The same variable, they will be bind together. Okay. 组成分呢，就是把一些类似的变项有共同的就归在一起，有点像我们不违规的有共同的共建性绑在一起。听懂吗？这些变数是几乎是平行的，几乎是同矩阵 ，OK 吗？所以两个变数的话就有同矩阵，还要绑在一起。比如说你在两侧数学能力啊，三角的函数能力啊，其实那些都是数量的。它要你不要绑在一起，同质性的能力，不然它会产生共线性。当然你也可以把它平均啊，你也可以把它数学平均嘛。OK， 冠位，事实上就是我们的数学平均，你把几题平均在一起，期中、期末考平均在一起，那是一个总成绩嘛啊。对啊，就是它类似一个加权，然后变异大的取算规律，那一个变数，如果这个老师每个人都打90分，多参考他一个对他没有影响，他对他没有影响，这样知道吗？只是加权，所以组成。Only 2 principal components, okay? Only 2 principal components. Eigenvalue higher than 1. And they can explain totally until 89.16%, right?
Yes.
两个组成分 eigenvalue 大1的话，两个组成分 yes, no rotation, but you can tell which variable belong to which component, right? You can define at the PCA factor to check the high value belong to how much and the sorting. You know what I mean? PCA factor, you can choose the PCA factor. PCA 里面，然后看 sorting value and the height, the loading. The loading if lower than 0.5 or 0.4, you don't need to show it. And eigenvalue greater than 1. Okay? And then 你就可以知道哪一个变数是属于哪一个组成分，好吗？比如说英文、国文就属于能力。然后统计数学。
So these 3 variables are grouped into one component.
And then you can see the table. You can see the table. Apply, okay, and run it. Maybe you change the data type, have the problem. Doesn't matter. And you can see the advance. They have a expert page frame. Just to show the eigenvalue larger than 1. Why? Why? Because when your data, you collect the correlation. That means all the variable data are standardized. If you choose based on covariance, that means you analyze the data, come with your measurement unit. 听懂吗？你选共变因数那一项，表示它带的单位在运算的。If you choose the correlation, that means all the raw data are standardized. You know You tried it? You find correlation and covariance. Okay?
Professor, we can see the script code here. Script code.
You cannot see the script block.
Yeah, in Modeler they don't show the script block. But doesn't matter. That data we can run in traditional interface. They show the scatter plot. Why? Because PCA is not for Modeler use. They just part of them.
Professor, in both factors there are all variables included. So,
Pardon me?
in both factors all variables are included. In the factor equation.
Yeah.
In the factor equation. All
Yes.
All the variables are included.
Yes. Yeah, all available for factor 2 equation. Yes, you want to write a principal component equation. You can write it. This is their coefficient. Their coefficient. Okay, equation for factor 1, factor 2. Yes, that's the principal 1 equation, principal 2 equation. Okay? You can write